Hi, welcome to the notes for H2-4. Today you will be rewriting quadratics in graphing form practice. You will practice and compare using the two methods for changing quadratics from standard form into graphing form. This lesson was originally designed as group work and as an exploration. However, being that we're in the situation we're in, I'm going to work through it. So if you want to follow along, you can. If you want to work on your own, go through it, that's perfectly acceptable. Please just make sure you double check your answers when you are finished. Let's get started. The directions here state, write the following equation in graphing form using two different methods. Then find the missing information listed below and graph the function. The first method that we're going to use is the method for graphing using averaging the intercepts. You did this already in Algebra 1. You reviewed this in Chapter H1-18. We're just going to do it again right now. Okay, so if we wanted to graph this by averaging the intercepts, we first need to figure out what those two X intercepts are. So to solve this equation, y equals x squared minus 2x minus 15, we first need to replace the y with a 0. So our output is 0. We have x squared minus 2x minus 15. Now we need to solve it, and you can use whatever method you want. However, if it's able to be factored, I would try to do that. That's going to be your easiest method for solving. So factors of 15 that have a difference of 2 would be 5 and 3. So we're going to need an x minus 5 and an x plus 3. And that still equals 0. We'll set each factor equal to 0 and solve it. And we get x equals 5 and x equals negative 3. What we found there is the two X intercepts. Our X intercepts are the points 5, 0 and negative 3, 0. Our Y intercept for this one, remember, ends up being our C term when it's in standard form. So we could say here that our Y intercept is 0, negative 15. And our vertex, well, we don't know the vertex, and we need to find that. Now, rather than graphing it, and there is a space for graphing this on the next page, so I'm going to jump over here. I know that my x-intercepts were at 5, 0 and negative 3, 0. Well, to actually find the vertex, okay, we're going to take it and we're going to average the x-intercepts. So to do that, we're going to say x equals the average of 5 and negative 3. So we're going to add them together and divide it by 2. 5 plus negative 3 is going to be 2. Divided by 2 gives us 1. So x equals 1 is our axis of symmetry. So that tells us here that our vertex lies on this line that runs straight down between those two x-intercepts. Now that we know that this line, x equals 1, is where the vertex is going to be, we also know that our vertex is going to have the point 1, something. To find the y-coordinate, we'll just take this input, 1, and plug it into the function. Y will end up equaling 1 squared minus 2 times 1 minus 15. So all we did is we took our x-coordinate and we substituted it in for x, and now we'll just solve it to figure out what y will be. This would be 1 minus 2 minus 15 gives us a negative 16. So when positive 1 is plugged in, negative 16 comes out. That is our vertex, 1, negative 16. So let's jump over here and put it on our coordinate plane. So I'm going to put it right here. This is the point 1, negative 16. And maybe I'll make those a different color so you can see them. Okay. Now when we try to graph, we usually try to use at least 5 points. So we do know that the y-intercept was at 0, negative 15. So we'll plot that there, and then we'll reflect it across and get this one. Now, if you understand that our stretch factor was 1, you could also probably put in another point, right? We could say if I go over 2 to the left, I go up 2 squared, 1, 2, 3, 4. There's going to be a point here. We'll reflect it across and put it there. And if I go over 3 to the left from the vertex, 1, 2, 3, 3 squared is 9. We're going to go up right there would be where the other point would be. So we can kind of have an accurate graph of our parabola here. We got, comes down through each of these points to our vertex, and now it comes back up and goes out this way forever. All right, so we just graphed that using the method of averaging the intercepts. You do need to know what that means. You will be asked to do that in the future by averaging the intercepts. Now let's compare that to completing the square. If we wanted to graph this just using this method, remember completing the square is where we're going to need to change it to vertex form or graphing form. And this is the skill that you just learned how to do in the previous lesson. So we'll take it here and we'll say y is equal to x squared minus 2x minus 15. We need to get it to be a perfect square trinomial, so I'm adding my 15 across. Remember, get rid of c. And since our stretch factor is 1, we can go ahead and look to complete the square. We have x squared minus 2x plus something should equal y plus 15 plus something. And this term here came from taking our b term, dividing it by 2, and squaring it. So our b term is negative 2. Negative 2 divided by 2 is going to be negative 1, and negative 1 squared gives us positive 1. So we're going to add a 1 here, and we're going to add a 1 here. And you'll see now that we've got y plus 16 is going to equal x squared minus 2x plus 1. Third step, factor the perfect square trinomial. This should end up being x minus 1 quantity squared equals y plus 16. Fourth and final step, get your k over onto the right side. So we subtract 16, and we end up with y is equal to the quantity of x minus 1 squared minus 16. And you'll see there, our vertex, right, would be 1 comma negative 16, which is exactly what it was over here. And then we could use our growth pattern to graph our parabola. So that's 2 different methods for graphing the parabola. We're not going to go through and overlap it, okay, it's already there. But, you know, the question is, which one do you prefer and why? So let's think about that here as we move on into the next problem. In this next problem, it asks us to write y equals x squared plus 8x plus 10 in graphing form using each method. Our goal here will be to find the vertex by averaging the x intercepts. Let's try it. So this one, to average the x intercepts, we have to find them. We're going to plug in 0 as our output and let it equal x squared plus 8x plus 10. Now, in the previous problem, we took it and we factored this, but this one doesn't factor. We don't have factors of 10 that will add to 8. So we're going to have to use another method for solving to find the x-intercepts. With a quadratic, we can always fall back on the quadratic formula. Let's go ahead and use it here. We know that the quadratic formula, we can find the x-intercepts by doing x equals the opposite of our b term. And let's write those out. A is 1, b is 8, and c is 10. So the opposite of b plus or minus the square root of b squared minus 4 times our a, which is 1, times our c, which is 10, all divided by 2 times 1. And as we go through and simplify, we'll have negative 8 plus or minus the square root of 64 minus 40 all over 2. And that gets us, what, negative 8 plus or minus the square root of 24, which simplifies to negative 8 plus or minus square root of, let's see, 4 times the square root of 6, so it'd be 2 radical 6 all over 2. And then we can simplify that. I think we did the same problem yesterday. So negative 8 over 2 plus or minus 2 radical 6 over 2 gives us -4 plus or minus radical 6. Okay, so you've been doing the quadratic formula since Algebra 1. We've already reviewed it, so you should be able to get to this point. Remember, this means that our x-intercepts are at the point -4 plus radical 6 comma 0 and -4 minus radical 6 comma 0. If we're looking for the vertex, right, we need to average these two like we did in the previous problem. We'll say here the average of the x-intercepts, okay, will equal, we'll take one of them, -4 plus radical 6, and then we have to add the second one, -4 minus radical 6, and we're going to divide it all by 2. Well, if you look at it here, hopefully you start to pick up on this relationship. Positive radical 6 and negative radical 6 will cancel out. You've got -4 plus -4 is -8 over 2, which reduces to -4. Our axis of symmetry will be at x equals -4. So hopefully you realize here that when you have the points that look like they're in this form, the x-intercepts, okay, you're going forward and backwards from -4, which means that your axis of symmetry is that -4. Great, now that we know that, let's go ahead here and find the rest of the vertex. The vertex we've got here is going to be the point -4 comma something. And now remember, we're going to take this -4 and we're going to plug it in for x in our equation. So y is going to equal, in parentheses, -4 squared plus 8 times, in parentheses, -4 plus 10. That's going to give us 16 minus 32 plus 10, which is going to be -16 plus 10, or -6. So the vertex is at the point -4, -6. Now that we know the vertex, right, we already know the stretch factor up here is 1. We can write it in our graphing form. So graphing form for that function would be y equals, remember, stretch factor is 1, so we don't have to write anything there. We're going to have x minus -4, would be like saying plus 4, squared minus 6. And that is our graphing form. Now you'll see that was quite a bit of work to find that there for averaging the intercepts. Let's see how this process works now for completing the square. So remember, we're going to take it here and we're going to solve it using completing the square. What we're going to do then, excuse me, we have y equals x squared plus 8x plus 10. Our first step, subtract the 10 from each side. We have y minus 10 is equal to x squared plus 8x. We'll look to make it a perfect square trinomial by adding something to each side. And when we do, remember, we're going to take b divided by 2 and square it. So that would be 8 divided by 2 squared is going to be 16. We'll add 16 here. And now we've got y plus 6 is equal to x squared plus 8x plus 16. And we can take that and factor it into x plus 4 squared. Now we subtract our 6 from each side, and we get y is equal to the quantity of x plus 4 squared minus 6. And now we have it in graphing form for this method. So the question here at the bottom states this: do both methods work for this parabola? In that case, I would say absolutely, yes they do. Next question, which method did you find easier and why? It's up to you which way you feel about that. In my opinion, I felt like the completing the square was easier for this particular function. That doesn't mean it's always going to be the easier method, but for me, I would have said the completing the square method was easier and more efficient. But remember, this is for this function only. You know, another function, it might be easier to do it with averaging the intercepts. And maybe you said in the last one, right, that possibly averaging the intercepts was easier on this one because it factored. You know, that was maybe a little bit easier than completing the square on this one. This one, it looks like completing the square was definitely the more efficient, probably a little bit easier method. All right, let's move into the next one. It says, can you use both methods to sketch y equals x squared plus 2x plus 4? Do both strategies still work? Let's take a little look at this one now. So if I wanted to do this one by averaging the intercepts, okay, let's start out with that. We'll do average the x-intercepts here. Okay, so when I look at this here, I'd put in my 0 is equal to x squared plus 2x plus 4. Hopefully you did that. Now, do we have factors of 4 that add to 2? We don't. So again, now we got to pull out the quadratic formula. Actually, let me change that. Let's do a equals 1, b equals 2, c equals 4. And we've got x equals a negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 all over 2 times 1. And as we go through it, negative 2 plus or minus 4 minus 16 all over 2. Well, we run into a problem here. Negative 2 plus or minus the square root of negative 12 over 2. Well, what's this mean if we have a square root of a negative 12? Well, I think the problem we run into here is this one doesn't have any x-intercepts, right? That means there would be no solutions. So all of a sudden here we run into a little problem there. There are no x-intercepts to average. Okay, so if we have no x-intercepts, that kind of throws that method out a little bit. And then let's see, you can complete the square here on this one still. Okay, if we look to complete the square, right, we've got 0. Actually, we don't even need to put 0 in because we're not solving it for the x-intercepts. We're just going to change the form. So let's get rid of c. We have y minus 4 is equal to x squared plus 2x. When we complete the square, we'll have x squared plus 2x plus blank equals y minus 4 plus blank. This missing number should be 1, and this side should be 1. So now we've got y minus 3 is equal to x squared plus 2x plus 1. What's this factor into? Should be the quantity of x plus 1 squared. So we get y is equal to the quantity of x plus 1 squared plus 3. Now that one worked out pretty easily. Now we could probably just graph it. So our vertex should be at the point negative 1, 3. Let's plot it on here. And now you see why this parabola has no x-intercepts, because the vertex is above the x-axis and it opens up. So we know the y-intercept is at 4, and we can reflect that. And then if I go, 2 to the right of my vertex, because it has standard growth, we know that we would go up 4. We can reflect it. If I go 3 to the right, I would go up 9, which I think is going to go off the graph. So we have enough here to put our graph on. We have 5 points already. And there we go. So I'll just go over these so you can see them and double check them on your paper. Make sure they're in the right spots. Okay, so do both strategies still work? Well, we just run into a little bit of a problem here, because if you're trying to average the x-intercepts, there aren't any x-intercepts in this problem. All right, let's move on. So a few questions for you. First one says, when does the method of averaging the x-intercepts work better? So if you think back to each of those problems that you've done, okay, it's probably easiest to do averaging the x-intercepts when you can find them more easily by factoring. So we'll write in there, when a function factors, to find the x-intercepts. That's probably going to be easier. Second question says, when does the method of completing the square work better? Well, I would say then probably when it doesn't factor, right? So, I'm getting low on battery, better hurry up, right? So when the function does not factor, and we could even put some extra detail in here, like saying, something like our B term. I think we liked when our B term was even, right? So we could even throw in here, especially when the B term is even. Right, that makes it easier to split. You don't have all those decimals and fractions, but it still works with decimals and fractions. We can't be afraid of those. And then which method is more efficient and why? This is just your preference, your opinion. In my opinion, I think that the completing the square is much more efficient, but it varies from problem to problem. So you can jot down whatever answer you feel is correct. There isn't really a wrong answer for that one. All right, so this one says, what is the vertex and y-intercept of the following function? We have y equals the quantity of x minus 3 squared minus 25. So the things that we're asked to find, the vertex and the y-intercept. Okay, well, vertex is going to jump right out at us here, right? We have x minus h here, and then we've got our k value right here. So the vertex we will end up with, right? If h is equal to 3 and k is equal to negative 25, our vertex will be at the point 3 comma negative 25. Our y-intercept is not negative 25. We need to put it into standard form to get that. So to get our y-intercept, we need to simplify this. Or, actually, let's do this. There's a couple ways we could do it. Remember, your y-intercept is going to have a 0 for your x, comma something. So if you wanted to take this and you wanted to simplify it, like we've done a little bit already, put it in standard form, you can do that. This is a very easy one to simplify. We have x squared minus 6x plus 9 minus 25. And that's going to give us y equals x squared minus 6x. And I think we're looking at minus 16. Okay, so we would say, well, the y-intercept is negative 16. Or, because it's a function and you know the x is 0, just put 0 in for x and solve it. Y equals 0 minus 3 squared minus 25. That's going to be a negative 3 squared, which is 9, minus 25 gives us that negative 16. So y is equal to negative 16. So either method there will work. Okay, so that's two different methods. Both of them work. Now it asks you to find the x-intercepts algebraically. All right, so x-intercepts, remember, have y-coordinates of 0. All right, so we know here that the y will be 0, so we're looking for what would the x be. Let's go ahead and plug in 0 for y and solve it. So the first thing we need to do, we're trying to get x by itself, so we're going to add 25 to each side. Now to undo the square, we're going to have to take the square root. And this is that important part that you must remember. The square root of 25 is 5. And the square root of the quantity of x minus 3 squared is the absolute value. Let me put that in color so you can see it. The absolute value of x minus 3. And remember, that means when we're looking at this, right, there's two numbers that would make this true. If I put a 5 in here, it would be true. And if I put a negative 5 in here, it would be true. That simply means that this x minus 3 is going to have to equal positive or negative 5. So then we're going to add our 3 to each side, and we get this expression that says 3 plus or minus 5 equals x. That means 3 plus 5 equals x, and 3 minus 5 equals x. So x is going to equal 8, or x will equal negative 2. Those are our x-intercepts. So we're going to say down here, well, we'll write it up here, we had 8, 0, and we had negative 2, 0. Those are the x-intercepts. This last slide is for you to practice these methods. The directions state, use the method of your choice to rewrite each function below in graphing form. Take your time, try one method. If it doesn't work well for you, try the other method. You will see the answers are written on here in the blue ink with the yellow highlighter. That way you know if you're getting to the correct answer or not. But remember, you can always graph your original function and your answer to see if it gives you the same parabola to check. Good luck. Let me know what questions you have. I will answer them either in class, or if you contact me through Remind or Google Meet, we can work on these. Thanks for watching.